Hello guys, this is CodeNCode and this is video editorial for the problem structuring the array taken from div 3 round 642D. So the problem is we are given an array of length n and initially all of the elements of the array are 0. So we have to choose a sub-array with maximum length, and if there are we have to choose a sub-array of maximum length such that all of the elements of the sub-array are containing value 0. Now if there are more than one such sub-arrays with maximum length, then we have to choose one with the leftmost starting point. So after that, what we do, we simply you don't have to worry about this. All you can do is this: initially the array was of length 5, so all 5 values were 0, so the maximum length sub-array containing all 0 element would be 1 to 5. Now the mid element would be 1 plus 5 divided by 2, which is 3, and this is an integer division. So you see, we got index 3 or mid value 3, so 3 will be initialized with count, and count will initially be 1, and then 2 and 3. After each iteration it will increase by 1. So initially count was 1. The maximum sub-array containing all element 0 was from 1 to 5, so mid would be 1 plus 5 divided by 2, which is 3. So 3 will be initialized with 1. So you see, now the array looks like this. Now we have two sub-arrays with length 2, all element containing 0, starting from 1 to 2 and then 4 to 5. Now there are two sub-arrays with equal length. Now we have, so we will choose the one which is having minimum starting point. So minimum starting point, this sub-array is having minimum starting point, so L and R are 1 to 2. Now again calculate mid, which is 1 plus 2 divided by 2, which is 3 by 2, which is 1. So 1 will be initialized with count. Remember, count was 1, and after this operation count became 2. So now we will initialize this with count. So position 1 will be initialized with 2, and then count increments, and count is now 3. So now we have two active range, one is, or two sub-arrays. One is this, which is 2 to 2, and another one is this, 4 to 5. So now the maximum length is of course of length 2, and the sub-array is from 4 to 5. We'll do the same thing again. 4 plus 5, 9, 9 by 2 is 4. We'll initialize 4 with 3, which was our count, and then we will increment the count, so count would become 4. Now you see the array looks like this. Now we have two sub-arrays with equal length, and starting from 2 to this sub-array is from 2 to 2, and this sub-array is from 5 to 5. We'll choose the one with leftmost starting point, so we'll choose this sub-array 2 to 2. Again 2 plus 2 divided by 2 is 2, so index 2, the position 2, not index, position 2 will be initialized with 4, which is the count. Again count increments and so on. So this is what we have to do, and this is the final array that we have to print. So to do this, what we are going to do, we are going to since we have to choose at each iteration the element with maximum sub-array size, so what we will do, we'll use some kind of priority queue. Now priority queue is a data structure which we can use any data structure which is able to give us the maximum length sub-array. So in the priority queue we'll be storing a tuple of this thing. First will be the length of the sub-array, second will be starting and ending point of the sub-array. So initially of course length would be 6, and starting and ending would be 1 to n, right? So in the priority queue we have saved this. Now this being the only tuple, so we'll pop out this only thing and we'll calculate the mid. So mid comes out to be 3. We'll remove that tuple from priority queue, and the new first of all 3 will be initialized with count. Count was 1 and now count is 2. Now new active range will be, now since initially the active range was from 1 to 6, now mid has been initialized, so now the active range is divided into two parts. L to mid minus 1 and mid plus 1 to R. So this is what we are doing here. L, which was 1, to mid minus 1, mid is 3, so new active range would be 1 to 2, and another one would be mid plus 1 to R. Mid was 3, so of course 4 to 6. This active range contains length 2 and this active range contains length 3, so these two tuples would be inserted in active range. Now the active range contains, the priority queue contains two tuples. Out of these, maximum length subarray is this. So we have to sort, or we have to find the maximum, we have to find the tuple which is having maximum length, right? So what we are going to do, of course in the next iteration this will be popped out, and for that we can use priority queue, because priority queue is actually priority queue can be used as min heap and max heap, and since this time we want the maximum subarray with maximum length, so we can use max heap. So if I show you the code, LLI is long int. If I show you here, so LLI is long int, even though in this case, in this problem we don't need it, but that's okay. So in each time we are reading n, and then we are calling the function fill n with passing the parameter n. After that we are running a loop from 1 to n, and from array AR we are printing the result, and array AR is an integer array, long int array, to store the result. Now the important thing is this fill n function. Now we are creating a priority queue to store a tuple with 3 values. So in the priority queue we'll be saving a pair, and the pair, the first value of the pair would be an integer to store the size of the subarray, and the second value would be another pair to store L and R. Now once you declare this priority queue in C++, this is actually a max heap. So this will give you, when you call the priority queue.top, it will give you the element which is having the maximum value by first element of the tuple. So first element of the tuple will be storing as the length of the subarray. So the top would contain the maximum, the subarray with maximum length, right? Now to initialize this, what we are going to do, in the priority queue initially we'll insert n, which is the size of the subarray, and 1 to n. Why I'm storing the negative values here is the reason this. Now for we popped out the second subarray, and this would be the mid element, and after calculating these are going to be the new active ranges. So you see, after you have popped out this, now you are left with these two, right? Now both of them are having the same subarray size, so we are having a clash at first value. Now priority queue sorts all of the element from left to right based on the values of the tuple stored from left to right. So first it will compare this, but both of the subarrays are having same first value in the tuple, which is equal to 1, which means subarray size is same. Now we have to choose the one which is having the minimum starting point, right? So this should be the next candidate, because this is having the minimum starting point. But if you declare max heap, the second value is L, which needs to be compared, because this is having a clash, because there are two subarrays having same first value. Now it will go for left, and what it will do, it will give you this, because after having a clash at the first value, it will compare the second values, and it will give you the tuple which is having maximum second value. Because we have declared a max heap, so it will give you the one which is having maximum priority. So it will give you this, but in the answer we want this. To get around this condition, what you can do, you can store the value while you are saving the range. You can make them all negative, so it will become -4 to -4, and it will become -6 to -6. If we see from -4 and -6, the maximum element is actually -4. So when you do this, when you store the ranges in with negative sign, what you are going to get is this, which is what we exactly want. So that is why while storing the tuple, I am storing first the subarray range, then L and R I am storing in negative value. So what we are doing in each iteration, while Q contains at least one subarray, one active subarray, we will get the L, SS is second and FF is first. So FF is first, SS is second. So what we'll do, of course, since in the priority queue the top will contain this tuple, which is actually a pair, and I want L and R, which is actually the second element of the pair. So I'm going to get the, from top I'm going to get the second, which takes you here, and after that the first is L and the second is R. So q dot top dot first, which takes you here, and then dot first, which will give you L, dot second will give you the R. So I'm taking that their negative values, because of course I have stored negative values of L and R. After that we are simply removing this from the priority queue. We'll calculate mid. In the answer array at index mid, we'll initialize it or store the value count and increment the count. If L and R are same, which means the range contains only one value, which is going to be mid itself. So you have taken care of that element, and this range cannot be used to create new active ranges. So we will simply continue for the next iteration. Otherwise, if mid is strictly greater than L, that means the new active range, that is L to mid minus 1, will contain at least one element. So in that case, new range would be L to mid minus 1, right? And again storing the negative values. Number of elements in this range would be mid to mid minus L. The second active range will be if mid is strictly smaller than R, so that mid plus 1 to R will be a valid range. So mid plus 1 to R will be new range. Again we are storing the negative values of them, and the number of elements in this range are going to be R minus mid. After this whole while loop is executed, your AR array is actually containing the whole answer. And finally, after calling this fill-in function, you can print all of the values. So this was simply an implementation problem from Codeforces. So this was how you solve this problem. If you have any doubt or query, of course you can ask in the comment section. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.